So in this problem, we're told that a particle of mass m equals 2.5 grams is initially at a position at rest at a position r equals 4.5 x hat plus 2.0 y hat plus 3.0 z hat meters, and it is acted upon by a force F equals negative 1.5 x hat plus 2.0 y hat plus 3.0 z hat newtons. Now we're first asked in part A what the vector A acceleration of the particle is going to be, and of course that's just going to be the vector F divided by m. However, in order to make the units work out, remember that newtons has a term of kilograms, and this is still in terms of grams. So this is just going to be 2.5 over 1,000 kilograms in order to make it a more reasonable unit, which is the same as 1 over 400 kilograms. And so now we can do this calculation. F divided by m is just F times 400. So we're going to get negative 600.0 x hat plus 800.0 y hat plus 1200.0 z hat newton meters. Meters per second squared. In part B, we're asked what the instantaneous torque on the particle is going to be that is brought about by the force F. And of course, remember that torque is just r cross F. So all we need to do is take the cross product of these two vectors, and this is going to be 2 times 3 is 6, minus 2 times 3 is also 6. So 0 times x hat, so I'm not going to write that term. There is no x hat term. Y hat is going to be 3 times 4.5, which is just 13.5, minus 3 times negative 1.5 is minus negative 4.5, so plus 4.5 y hat, plus, and then for the z hat term, we're going to have 4.5 times 2 is 9, 9.0, minus a negative 3, so plus 3.0, z hat, and this is going to be in newton meters. And so this is going to come out to be 18.0 y hat plus 12.0 z hat newton meters. Finally, in part Z, we're asked what the angular momentum of the particle is going to be for very short times t, for which r and f will not have changed appreciably. And so what that means is that since L is equal to r cross p, and torque is dl dt, L of t is going to be approximately r of 0, because remember r has not changed appreciably, cross p of 0, which is simply m times v, cross p of t, plus torque times t, because if r and f are not changing appreciably, torque is not changing appreciably, so we can simply treat torque as a constant. So, I was right the first time. This is p of 0. R of 0 cross p of 0 is going to be just 0 because the initial momentum is very, very small. So if r has not changed appreciably, the velocity cannot be very large. So this is going to be approximately equal to torque times t. And so for very short times t, the linear momentum is just going to be 18.0 t y hat plus 12.0 t z hat. And that's going to be in units of kilograms, meters squared per second. So these are our final answers. We have the acceleration, the instantaneous initial acceleration of the particle, the torque of the particle at time t equals 0, and the approximate angular momentum for very, very small times t.